Okay, here's another example of total area from 15.4. This is example number 6b. It asks us to find the total area, so that's a key word there, the total area between the x-axis and the graph of x squared minus 4 from x equals 0 to x equals 4. Now on the last example, I gave you a picture. On this one, I did not, but it might help for you to draw a picture. So do you have any idea of what an x squared minus 4 graph looks like? And can we use that to kind of sketch a graph? It might not be perfect, but it might give us a good idea of what we're looking at. So we should know that an x squared minus 4 graph is a parabola. It opens up and it's shifted down 4. So my, okay, not so beautiful picture looks like this. And it asks us to find the area between the x-axis and the graph from x equals 0 to x equals 4. So 0 is over here. I don't know, 4 is somewhere over here, but I'm not really sure. And the area between the x-axis and the graph kind of looks like that. So again, if they're asking me for total area, I have a red flag here that says that I have some area that's below, negative, and I also have some area that's above, positive. And what I need to do is I need to make sure that I take the area here and take as absolute value, the area up above, and so that I can add them together so they don't negate each other. They're not asking me for a net change, they're asking me for a total area. So anytime they ask us for a total area problem, we have to follow a couple different steps. The first thing we need to do is we need to figure out where our graph is above the x-axis and where it's below the x-axis. Where is it positive versus where is it negative, right? And when they gave us a picture, it was kind of easy. But without a picture, it's a little bit harder. So we've got to be a little bit more careful. And so my picture is absolutely just a rough sketch, but I know that I have some area below and I have some area above. And it's at this point where it crosses the x-axis that changes. And so I actually have to find that point where it touches the x-axis, where my function equals 0, so that I could figure out when my graph is positive versus when it's negative. So let's pretend that I didn't have the picture anymore, right? So kind of cross that off, cover it up. We'll maybe use it later to kind of reference to make sure that our answers make sense. But let's pretend like we didn't have the picture. Let's go back to our original problem and let's work through finding the total area without a picture. Okay, so the first thing again we want to do is we want to figure out when our graph is positive versus negative. When is it above the x-axis versus when is it below? And so we can determine that by figuring out first, where does it equal 0? Where does it touch that x-axis? And then once we find that number, we can figure out right before that number, is it positive or negative, above or below? Right after that number, is it positive or negative, above and below? So let's do that now. Let's take our function, my x squared minus 4, and let's figure out when it equals 0. Where does it touch that x-axis? I'm going to add 4 to both sides. I'm going to square root. Now be careful. I end up getting x equals plus or minus 2. And if you remember, back from our picture, doesn't it touch at both x equals negative 2 and x equals positive 2? We're not necessarily concerned with the negative 2 piece on this one, but we are concerned where it touches the x-axis at x equals positive 2. So we want to find the area from 0 to 4, but at x equals 2, right in the middle, it changes a little bit. Okay, so again, pretend like we don't have that picture, but we do know that my function equals 0 at x equals positive 2. And so now I'm going to think about kind of a number line. I know that I want to start at 0. I know that I want to find the total area until I hit 4. But at x equals 2, it touches the x-axis. Now if I didn't know what the picture looked like, I've got to figure out from 0 to 2, is it above or below? And from 2 to 4, is it above or below? And so I can figure that out by testing values, kind of like we've done in the past, where if I have my function, my x squared minus 4, and let's pick an x value in between 0 and 2. So let's say 1. If I plugged in 1 to my function, I ended up getting negative 3. And so what that means is that my y value, my output, is negative, which means my graph goes underneath my x-axis. From 0 to 2, the area that I have there is negative. Let's test a value from 2 to 4 and see where my graph is at. If I test a number between 2 and 4, I don't know, let's say 3. If I do 3 squared minus 4, plugging it into my function, I end up getting 9 minus 4, which is what, positive 5? So I know then that my y values are positive and my graph goes above the x-axis. It might not be perfect, but now I at least know where I'm negative versus where I'm positive. And then I know that if I'm asked to find the total area, I have to now separate my problem into two different integrals. So that's step number 2. Wherever I'm positive versus wherever I'm negative, I've got to set up my problem into two different integrals so that I'm careful with separating those two different pieces. And so I'm going to set up two different integrals, one from 0 to 2 of my function, and then one from 2 to 4 of my function. And when we set up the integral from 0 to 2, we know that the answer is going to be negative, and then we need to make sure that we add absolute values around it. So I've set up my two different integrals. I have my integral from 0 to 2 of my function, plus my integral from 2 to 4 of my function. I'm going to use my fundamental theorem of calculus and my integration rules. I'm going to evaluate my upper limit minus my lower limit for each little piece. From 0 to 2, I ended up getting negative 16 over 3. And from 2 to 4, I ended up getting an area of 32 over 3. That negative should be that red flag. Remember, that was the place where it was below the x-axis here. And I don't want net change, I want total area. So I don't want to use the negative version of 16 over 3. I want to use the absolute value of it. So really, I want to take positive 16 over 3, the area from 0 to 2, plus the 32 over 3, the area from 2 to 4, and add those together to get my total area. We should end up getting a total area of 16. But the only way that we were going to get that correct answer is by separating it into two different integrals. Okay? Figuring out when your function is positive or negative, setting up two different integrals, and then taking the absolute value of the negative part so that you can add them together for total area. Okay? If you didn't do that and you tried to just integrate it straight up the way it was from x squared minus 4 from 0 to 4, you would end up getting 16 over 3 and not 16, which is very different. This is more of a net change, including the positive and negative versions, where the 16 is a total area amount. A little bit different and makes a big difference in your answer and what they're asking for. So be careful. If you're